Good afternoon, all of you. So please note down the example on the resultant of concurrent force system shown on the screen. Determine the required tension in cable AC, knowing that the resultant of three forces exerted at point C of a boom must be directed along BC and the corresponding magnitude of resultant. So three forces are acting at point C. What are those three forces? 75 Newton acting vertically downwards, 50 Newton making an angle 25 degrees with respect to vertical, and tension in the cable AC, right? So the tensile force, it always acts away from the point. So it is acting from C to A. Now the resultant of these three forces must be directed along BC. So it is given that the resultant of these three forces is acting along the line BC. Then you have to find out the tension in the cable T and the magnitude of resultant R. Okay? So I will take.
Sir.
Yes.
Is the 15 Newton force perpendicular to the beam?
From the geometry, you can find out the angle. See, here it is 35 with respect to vertical, so it is 35 plus 25. How much? 16. So it is not perpendicular. Okay. So taking horizontal axis as x, vertical as y, you have to resolve each force into xy components. For that, you must know the angle made by the forces either with respect to x or y. Now see this right angle triangle A, C, D. I am drawing a horizontal line over here. You have this is 65, 90, and this angle is 25. Similarly, considering the right angle triangle BDC, you have this as 35, 90, therefore this angle is 55. So 55 is the angle made by the resultant with respect to horizontal. 25 degrees is the angle made by tension with respect to horizontal. Now we know that the algebraic sum of all the forces is equal to resultant. The algebraic sum of x components of all forces gives you x component of resultant. Am I right? Now let us write the x components of all these three forces. For 50, x component is towards right, y component is downwards, 75 is along y, and for tension, x component is towards left, y component is upwards. For resultant, x component is towards left, y component is downwards. Yes. Now what is the x component of 50 Newton force? 50 is making 25 degrees with respect to y. So y component is cos, x component is sine. So it is 50 sine 25. What is x component of 75? 75 is acting along y axis. Its x component is 0. X component of t, it is acting towards left, minus t, making an angle 25 with x. So it is cos 25. This is equal to x component of resultant. Again, resultant is x component is acting towards left. So minus r cos 55, making an angle 55 with x. So this is equation 1. Similarly, algebraic sum of y components of all forces is equal to y component of resultant. What is y component of 50? Minus 50 cos 25, right? Minus 75 40 plus t sin 25 is equal to y component of resultant minus r sin 55. Say equation 2. Solving these two simultaneous equations, you can get the values of t and r. Tension in the cable and the magnitude of resultant. Are you ready with the answers?
Yes, sir.
So what is the value of T?
35.05 Newton.
Please check your answers.
37.5.
Almost 88, sir.
37.26.
87.65.
T is 87.16 and the
Sir,
result is
88.86 not correct.
0.08.
Sir, the answer 88.86 is not correct.
Okay, no problem. So finally, these answers are very important. That means you have to be very careful with the calculations.
sir, I got R is 101.65. Is that fine?
Yeah, 10.
1.65.
Yes, will do.
Sir, I got 103.27.
No problem. Will be considered.
Yes, sir.
You can explore of doing calculations in the calculator. You can do these solve these equations directly by putting the coefficients of t, r, and constant like a, b, c. Parallel force system. So till now we have solved examples on concurrent force system. Now how do you find out the resultant of parallel force system? Parallel force system means all the forces are acting in the same direction. If all forces are acting horizontally, simply by taking algebraic sum in x direction, you will get the resultant. If all forces are acting vertically, then you take algebraic sum in y direction, you will get the resultant. So that gives you magnitude of resultant depending on the sign of summation fx, summation fy, plus or minus. You will get it as towards right or left, upwards or downwards. That means this gives you magnitude of resultant, direction of resultant. Direction is same as that of the given forces, and the sense of the resultant depending on the signs of summation fx, summation fy. Now, how do you find out the position of resultant? Where the resultant is acting? For concurrent force system, we know that it will act at the point of concurrence. So, for parallel force system, how do you find out the position of resultant? Anybody?
Varignon's theorem.
Varignon's theorem.
By using Varignon's theorem. So you can select any point of your convenience and you take algebraic sum of the moments of all those forces about that point. That must be equal to moment of resultant. That is R into D. R is the magnitude of resultant. D is the perpendicular distance from the line of action of resultant to the point. So by knowing this summation M and R, you can locate the position of resultant for parallel force system. Okay. So let us solve an example. 3 hikers are shown crossing a footbridge. Knowing that the weights of the hikers at points C, D and E are 200 Newton, 175 Newton and 135 Newton respectively, determine the horizontal distance from point A to the line of action of the resultant of the 3 weights when A is equal to 3.3 meters. Length of the footbridge is given 18 meters. Hikers are standing at C, D and E and their weights 200, 175 and 135. Distance from A to C 4.5, from C to D is A is equal to 3.3 meters and from D to E 1.5 A. Here all these 3 forces are acting vertically downwards. So taking algebraic sum in y direction gives you the magnitude of resultant. So it is minus 200, minus 175, minus 135. So it is minus 510. So the magnitude of resultant 510 Newton, direction is vertical, sense is downwards. Now you have to find out the position where the line of action of resultant acts with respect to point A. Let the resultant B acts at a distance x meters from A. So 5 Newton acting downwards. The position of resultant with respect to A is x meters. Now to determine x, taking moments about point A and using Bernoulli's theorem. So algebraic sum of the moments of all forces about point A is equal to moment of resultant about point A. Now you tell me what is moment of 200 Newton about point A? It is forming clockwise moment. So minus 200 into perpendicular distance from the line of action of the force to point 4.5. Moment of 175 again forming clockwise, minus 175 into perpendicular distance 4.5 plus A. So 4.5 plus 3.3. Moment of 135 again clockwise, minus 135 into the perpendicular distance, is total distance 4.5 plus A plus 1.5 A. So it is 4.5 plus 2.5 A. 2.5 into 3.3. This is equal to moment of resultant above A. Again the resultant is forming clockwise moment. So it is minus resultant is 510 into perpendicular distance is x. Solving this equation, you will get where the line of action of resultant acts with respect to 7.81 meter from A. 5 horizontal forces are acting on the rod AB, which is inclined to the horizontal at 25 degrees. Determine the resultant of these forces with respect to point A along the rod AB. A point to be noted. You have to find out the resultant, position of resultant with respect to point A along AB. That is important. Along AB. So first we will find out the magnitude of resultant. Here all forces are acting in x direction. So summation Fx is equal to R is equal to minus 5 plus 5 minus 8 plus 12 minus 9. That is minus 5 Newton. So magnitude of resultant is 5 Newton, direction is horizontal, sense is towards left. Now to find out the position of resultant, let the resultant is acting horizontally towards left at a distance, perpendicular distance D from point A. Right? Resultant is acting horizontally towards left. That D is the perpendicular distance from the line of action of resultant to point A. Now to find out D, we can use Verignan's theorem. So taking moments about point A and using Verignan's theorem, moment of this 5 Newton will be 0. We have a algebraic sum of the moments of all these forces. Moment of this 5 Newton which is acting at A will be 0. The line of action is passing through it. Moment of this 5 Newton which is acting at C about A will be clockwise. So it is minus 5 into what is the perpendicular distance from the line of action of this force to point. We know that this angle is 25, hypotenuse is 1 meter, opposite side is 1 sine 25. Am I right? So this perpendicular distance is 1 sine 25. Now moment of 8 Newton, sense is anti-clockwise, plus 8 into perpendicular distance from the line of action of this force to point A. Now see this hypotenuse, 1 plus 2, 3 meters. Again this angle is 25, opposite side, 3 sine 25. 3 sine 25. The moment of 12 Newton about A, sense is clockwise, minus 12 into perpendicular distance. Now see this total distance, 1 plus 2 plus 2, 5 meters, opposite side. So it is 5 sine 25. Are you following me or not? For these horizontal forces, vertical distances are perpendicular. You know this 25 degrees. So the vertical distance means it is the opposite to 25, which will be sine. Sine of this hypotenuse. Yes. Now moment of this 9 Newton about A. 9 into perpendicular distance is total distance is 6. 6 sine 25 into 6 sine 25. This is equal to Moment of resultant above A, sense is anti-clockwise. 5 into perpendicular distance is D. So solving this equation, you will get D. But D is not our answer. What is D?
1.13.
1.13. Right. But you have to find out where the line of action of resultant, the position of line of action of resultant with respect to A along AB. That means you have to find out this distance x along AB. So from this right angle triangle, sin 25 is equal to D upon x. 1.13 upon x. That gives you x. Position of resultant with respect to point A along AB.
.6 meter.
Right. So 2.6 meter with respect to A along AB. Okay, any doubts? Parallel force system, very simple. Next, general force system. General force system, it is non-concurrent, non-parallel force system. So let us see how you can find out the magnitude, direction, point of application and the sense of the resultant. Let us consider this plane A, B, C, D. Let F1 is acting at point B, making some angle. F2 is acting at point C. F3 is acting at point B. Say three forces are acting in the plane. And these three forces are neither concurrent nor parallel. So it is general force system. Now to find out the resultant, I will select a point in the plane, any point of my convenience. To my convenience, I am going to select point A. So with respect to A, I will define the position of resultant, where it is acting. Okay. So to define the position, you must have some reference point. So the reference point can be anywhere in the plane. Now, by principle of parallel transfer of forces, I will transfer all these three forces from the points B, C and D point A. What is principle of parallel transfer of forces? When a force is transferred parallelly from one point to another point, that force is accompanied by a moment whose magnitude is force into perpendicular distance, right? So by doing so, we are not changing the effect of the force on the body, right? Now, I will transfer this force F1 from B to A parallelly. That means the direction of F1 remains same, transferred parallelly. Now, it is accompanied by a moment whose magnitude is F1 into perpendicular distance. And what is the sense of that moment? Anti-clockwise. So it is accompanied by an anti-clockwise moment of magnitude, say M1. Is it clear? Similarly, transfer F2 from point C to point A parallelly. It is accompanied by a moment. What is the sense of the moment? F2 is forming clockwise moment of magnitude M2. Transfer F3 from D to A parallelly. That F3 is accompanied by a moment clockwise, magnitude M3. Is it clear? So all these three forces are transferred parallelly to point A, but the effect of these forces remains same. We are not changing the effect. Now at point A, we have a system of concurrent forces. F1, F2, F3, all are passing through point A, right? That means now the given system is reduced to a simple system with concurrent forces at point A, say F1, F2, F3, along with a resultant moment. So from this M1, M2, M3, you can find out the resultant moment taking algebraic sum. If it is anti-clockwise, positive, clockwise, negative, minus M2, minus M3. So you can find out the resultant moment. So at A, you have a resultant moment, summation MA. Is it clear? So what we have done, this non-concurrent, non-parallel force system is converted into a concurrent force system at A along with a resultant moment summation MA. So the effect of these two systems remain same. Right. Now we can easily find out the resultant of this concurrent force system. So resolving each force into xy components, summation fx, summation fy, r is equal to square root of summation fx square plus summation fy square, direction tan inverse summation fy upon summation fx. Right? So in the third step, now A, B, C, D. I am replacing F1, F2, F3, these three concurrent forces with a resultant force, say R. There is a resultant moment also. So summation NA. So again, these two systems are equivalent. Understood? The first step, we are converting the given system to a concurrent force system at a particular point along with moment. Next, we are replacing the concurrent force system with a single force, that is the resultant force, along with the moment. Further, you can add these two. When a force and a couple or moment are added, resultant will be a force which will be transferred parallelly by distance d given by moment upon force. Are you getting me or not? See, when you are saying a force is transferred parallelly, say from point A to point B, that force is accompanied by a moment which is force into this perpendicular distance. Now when you combine this force and moment, the resultant will be the force which will go back to its original position by distance d given by moment upon force. So this reverse process we are doing over there. We are adding the force and moment. So the resultant of force and moment will be the force which will be transferred parallelly by distance d. So when you add this resultant and the moment, resultant force and moment, this resultant will be transferred parallelly by a distance d. Right? Parallel means the direction of the resultant remains same. So this d will define the position of resultant with respect to A. So in this given system, the resultant of this non-concurrent, non-parallel force system will be acting at a distance d from A. This is the position of resultant. Understood? Or do you have any doubt? You tell me, then we will proceed further. At this moment of time, do you have any doubt?
Sir,
Yes.
can you just summarize once again?
The given system is non-concurrent, non-parallel force system, right? By transferring all the forces parallelly from their respective positions to any reference point, let us A, we are converting the given system into a concurrent force system and a resultant moment. Is it clear?
Yes.
Now, at this moment of time, the given system is equivalent to this. In the given system, these three forces are acting at three different places. We are converting that to a concurrent force system at A, along with the resultant moment. Now, I am finding the resultant of these three forces, three concurrent forces. We have solved many examples on concurrent force system. I am replacing these three concurrent forces with only one force, that is resultant force, say R, along with the moment. The moment is there already, right? So first we are converting into a simple system having one force and one moment. Further, I am converting the simple system to the simplest system having only one force by adding, by combining this force and moment. When a force and moment are combined, resultant will be a force which will be transferred parallelly by distance d. So ultimately, this R is the resultant of the given system, which is acting at a distance d from A. Then how do you find out this d? D is equal to
Sir,
summation MA upon R.
Resultant.
Yes, here D is equal to M upon F. Here M means resultant moment, algebraic sum, summation MA. F means the resultant force, that is R. So D is equal to summation MA upon R. Right? Now say, with respect to A, I am taking this as x-axis. This is y-axis, vertical. The line of action of resultant is extended and it will intersect, say, x-axis at a distance x meters from A. Similarly, the line of action of resultant intersects the y-axis at a distance y. Now, by principle of transmissibility of force, I can transfer the resultant along the same line of action to this point on x-axis, and then I will resolve this into x and y components, say Rx, Ry. Now I will take moments above A. Algebraic sum of the moments of all forces above A is equal to moment of resultant. To find out moment of resultant, I will take algebraic sum of the x and y components of resultant above A. What is the moment of x component of resultant above A? Line of action is passing through it, 0. Moment of Ry, y component above A, it is Ry into x. So plus Ry into x. This gives you x is equal to summation Ma upon Ry. What is Ry? Ry is nothing but summation Fy. So by this x also you can locate the position of resultant. Is the line of action of resultant x at a distance x horizontally from point A. Similarly, by transferring the resultant along the line of action to the point on y-axis and resolving it into x and y components, taking moments above A. Algebraic sum of the moments above A is equal to moment of resultant above A. That is the sum of the moments of components above A. Moment of Rx is Rx into Y plus moment of Ry is 0. Line of action is passing through it. This gives you y is equal to summation Ma upon Rx, or y is equal to summation Ma upon summation Fx. So by calculating the perpendicular distance d or horizontal distance x or vertical distance y, you can locate the position of resultant with respect to a given point.